In this video, we're going to talk about sequence and series. So let's get started. What's a sequence? A sequence is a collection of numbers arranged in a predictable order. So what this means is if I have a number like 2, 4, 6, 8, 10, this is a sequence. Why? Because this is an arrangement of numbers. And they are arranged such that I can predict the order. I can predict in the sense that I can tell what comes next. So if you look at the sequence, I expect that what comes next should be 12 because I keep adding 2 to the current to get the next, right? And that is what makes a sequence. So then what about a series? What about series? Series can be said to be the sum of sequence. So if you add this up, you get series, right? So now let's talk about some terms you may come across. When you look at the sequence like this, we refer to this as terms. We refer to each of these numbers as terms. So you can say that the first term, which we write as T1, right, is 2. The second term, which is T2, is 4. And the third term, which is T3, is 6, and so on. So we refer to each of these as terms. So what about the how long can a sequence be? We have sequence that could run to infinity. So you could have sequence like this. So let's say you have 1, 4, then you have 7. So we keep adding 3, right? Now this could continue forever. If you have a sequence that continues forever, you call this an infinite sequence. Infinite sequence. Then if you have a sequence that terminates, so in the case of 2, 4, 6, 8, 10, 12, this one terminates, right? This is called a finite sequence. So it has an end. It has a last term. Finite sequence. So these are some of the terms you will come across in or under sequence. Now let's look at the various types of sequence. There is what's known as arithmetic progression. Arithmetic progression or linear sequence So this is a sequence where the difference between two successive term means two terms that are next to each other. The difference between those terms happens to be constant. So let's look at the example we gave earlier. So in this case, if you check the difference between 4 and 2, that is 4 minus 2, that's 2, right? 6 minus 4, that's 2. Then 8 minus 6, that's 2. So because the difference is constant, the difference between successive terms is constant, you call this arithmetic progression. So we have other examples like this. So you could have something like 5, then minus 2, then you could have something like minus 1, minus 4, and so on. So in this case, what's the difference? Minus 2. So this is 2 rather, not minus 2. This is 2. So in this case, 2 minus 5, that's minus 3. Then in this case, minus 1, minus 2, that's minus 3. Then in this case, minus 4, minus 1, that's what minus 3. Because the difference is the same, which is minus, we keep subtracting minus 3. This is also an arithmetic progression. So let's look at another example. This is known as geometric progression. Sometimes it's also known as exponential sequence. So what are examples of this? So in this case, the ratio is what is constant, not the difference. So let's take a look. So let's say I have something like 2, 4, then 8, 16, 32. Now look at the difference. In this case, we multiply 4 is this 2 times 2. 8 is the 4 which came before it times 2. 16 is the 8 which came before it, right? Times 2. So we keep multiplying by 2. So if you take the ratio between 4 and 2, that is 4 divided by 2, that will give you 2. Take the ratio between 8 and 4, that will give you 2. The ratio between 16 and 8, that will give you 2. So because the ratio between two successive terms is constant, we call that geometric progression. So let's take a look at another example of sequence. So in this case, we have Fibonacci sequence. Fibonacci sequence. This is not a very common sequence in math. I mean in elementary math, but it's a common sequence in other aspects of life. So what is Fibonacci sequence? So I'm going to give you an example. Fibonacci sequence starts with two terms, 0 and 1. So this is the first term, this is the second term, but basically you have to start with these two. So how do you get the next term, which is the third term? You get the third term by adding the previous two terms. So 0 plus 1, that will give you 1. So how do you get the fourth term? You add the previous 2. So that's 1 plus 1, that will give you 2. So what about the next? 1 plus 2, that will give you 3. Then what about the next? 2 plus 5, 2 plus 3, that will give you 5. Then the next is 3 plus 5, that's 8. Then the next is 5 plus 8, that's 13, and so on. So this is an example of Fibonacci. In fact, this is basically Fibonacci sequence. So what that means is Fibonacci sequence is a specific type of sequence, not a sequence of various types. This kind of sequence is known as a Fibonacci sequence, where you add the previous two to get the next. So let's take a look at another one. Another one is known as harmonic sequence. Harmonic sequence. So in this case, you have, it's like arithmetic progression that has been inverted. So let's say this is a typical um, arithmetic progression. So if you take the reciprocal, which is 1 over 2, 1 over 4, and 1 over 6, and 1 over 8, this becomes harmonic sequence. So there are other type of sequence, but I'm going to stop here. So now let's focus on the major sequence of today, which are arithmetic progression and geometric progression. These are the sequences. These are the sequences that you will come across in most exams: arithmetic and geometric progression. So these two will be the focus of our discussion today. So let's start with the first one, which is arithmetic progression. So let's take an example. Here you have 5, then 10, 15, 20, and so on, right? So what we want to do here is we want to come up with a formula for calculating any term of an arithmetic progression. So what that means is, given a particular arithmetic progression, what is the formula for calculating any term, maybe any nth term, right? So before we can derive that, let's define some term. So the first term we want to define is T1. T1 is the first term, and we're going to represent that as A. Then what about the common difference? The common difference is the value that you get when you subtract two successive terms. So we want to represent that with this. So common difference. The common difference is T2 minus T1, and it's also T3 minus T2, and so on and so forth. But we represent it as D. That's the symbol we're going to use to represent the common difference. But then I'm going to give you another formula for calculating D. So imagine you don't know two successive terms. So imagine you know the t, you know the 10th term and the 5th term, for instance. How do you calculate d? This is a very shortcut for calculating d in that case. Just say tn minus tm divided by n minus m. So just take a difference between any term. So what I mean by that is, so if I know the first term and I know the fourth term, so in other words, if I were given the first term and I know the fourth term, right, and I want to calculate the common difference, I can simply do that by taking 20, which is the fourth term, minus 5, which is the first term. Then I'm going to divide by 4, right? This is the fourth minus 1, which is the first step. So if you take this difference, you're going to get 15 divided by 3, and that will give you 5. So this is a very interesting formula for calculating the common difference, given that you know any given term, any two term. Okay, so what about Tn? What is the nth term? Given you know your first term and you know your common difference. The formula is given as A plus n minus 1d. So this is the formula for calculating the nth term of an arithmetic progression. Okay, so let's talk about the series. So this is for the sequence. So what about the series? What formula can you use to calculate the sum of terms of arithmetic progression, to calculate the series of arithmetic progression? So let's take a look at this. Given that you know the first term and you know the common difference, the sum of term, that which is a series, is given as n over 2 into brackets 2a plus n minus 1d. You can also write it as n over 2 into bracket a plus l, where L equals to the last term. So this second formula applies in a case where you have a finite sequence, where you know the last term and you know the first term, and you want to sum all the sequence. So these are the two formulas you should take note of. The formula for calculating, these are the three formulas. You need to take note of this, then take note of the formula for calculating the nth term. Then you also take note of the formula for calculating the sum of the terms in the sequence. So we're going to look at some examples from past questions. But before we do that, I would like us to talk about the geometric progression. Then we'll look at some past questions. So let's talk about geometric progression. In the case of geometric progression, you multiply a number to a current term to get the next term. So let's take a look at an example. So if you have 2, 4, 8, 16, and 32. In this case, you'll notice that we multiply 2 to 2 to get 4. We multiply 2 to 4 to get 8, and so on. So in this case, we are multiplying. So because we are multiplying, you call this geometric or progression or exponential sequence. So what are the things you need to know about geometric progression? So let's talk about the things you need to know. So the first thing is you need to take note of the first term. So we represent the first term as A. Then another thing you need to know is what they call the common ratio. The common ratio is that number you keep multiplying to get the next. So you get that number. The common ratio is represented as R, and and you can calculate it by dividing the successive terms. So you can divide T2 by T1, and that will give you the common ratio. Or you divide T3 by T2, or you divide T4 by T3. But in a case where you don't have two successive terms, how can you get R very quickly? Now there is a shortcut for that. So you can just take, let's say you have any two given term, and those two terms are Tn and Tm. They may not be successive, they may not be close to themselves, right? How do you get the common ratio? You can get it as follows. Just have Tn divided by Tm, then raised to the power of 1 divided by n minus m, right? So this is the general formula for calculating common ratio very quickly. So let's take a look at this example. We know that the common ratio is 4 over 2, which is 2, or 8 over 4, which is 2, or 16 divided by 8, which is 2, right? But what if you are given the fifth term, which is 32, and you are given the second term, which is 4? How can you quickly get the common ratio? Let's say you don't know any other term, just know the fifth term and the second term. The common ratio can be calculated as follows: 32 divided by 4. Everything raised to the power of 1 over. What term is this? This is the fifth term, right? Then what term is this? This is minus the second term. So if you divide this, you're going to get 8 raised to the power of 1 over 3. And you can easily solve for this by just saying 2 raised to the power of 3 times 1 over 3, then 3 cancels out 3, then the answer is 2. So you can easily get the common ratio given any term, given any two terms, right? Without going through any complicated process. So now that we know our first term and we know the common ratio, what is the formula? What's the formula that represents any given term, any nth term? So here you have Tn, which is the term for any term. You can calculate any term by as follows: a times r raised to the power of n minus 1. So let's check it out. So if I want to get the second term, for instance, given this example, the first term is 2, right? Then common ratio is 2 raised to the power of second term. This is n is 2, right? 2 minus 1. If you check this out, you get 2 times 2 raised to the power of 1, and that's 4. And if you try that for the fifth term, that's 2 times 2 raised to the power of 5 minus 1, and that's 2 times 2 raised to the power of 4, and that 2 raised to the power of 4 is 16 times 2, that's 32. So this represents the formula for calculating any given term of a geometric progression. So what about the sum? What formula can we use to calculate the sum? That is, what formula can we use to calculate the series of a geometric progression? Okay, so there are two scenarios here. We have scenarios where the common ratio is greater than 1, and you have a case where the common ratio is less than 1, right? So these are the two scenarios that you could come across. So that means I'm going to present two formula representing these scenarios. So the first scenario where you have your common ratio greater than 1, what's the formula for that? So the sum of a geometric progression where you have r greater than 1 is as follows. You take the first term, then you have r raised to the power of n, then you have minus 1 here, then divide by r minus 1. So that's for a case where r is greater than 1. Okay, for the other case, you just take this, which is r, this is now 1 minus r raised to the power of n. Just swap this. Then you have 1 minus r, and that's for a case where r is less than 1. So these are the two formula you should take note of for calculating the series of a geometric progression. But what if you have an infinite what if you have an infinite sequence, that is a sequence that does not terminate, and the common ratio is less than 1? Let me explain that in detail here. So look at this case. In a case where you have, let's look at these two scenarios. If you have 2, 4, 8, and 16, in this case, r is greater than 1. But look at the scenario. So if you have something like 2, then you have 1, then you have 0.5, that's 1 over 2, right? Then you have 1 over 4, then you have 1 over 8, and so on. In this case, r is less than 1, right? Okay, if you look at this carefully, you'll notice that in the first case, the value of Tn, that is every successive term goes up. If you check it, it goes up to infinity. If you keep multiplying by 2, it keeps going up. But in this case, the value keeps going down and it keeps going down towards 0. At some point, you will get something extremely close to 0. Now, in this first sequence, if you sum this infinite sequence, you will get infinity because the at the end of this sequence, that's you have infinity. But if you sum the sequence, you may not get infinity because this sequence converges towards 0. So converges means it's driving itself towards 0. And because it's driving itself towards 0, you can add them up. You can add something that is getting smaller. But you can't add something that is getting bigger because if it goes bigger forever, the sum will be infinity. But if it's getting smaller, that means at some point it's going to disappear into 0. It's going to become 0. So this kind of case, you can compute what they call sum to infinity, right? You can't compute that for this because the sum to infinity of this one is infinity. But in this case, you can calculate the sum to infinity without getting infinity as your answer. So what formula can you use to calculate the sum of this sequence to infinity? And if you sum everything to even up to when n is equal to infinity, what will be the answer? Okay, so that is what n sum to infinity means. So sum to infinity means take the sum for an infinite sequence, for an infinite geometric progression, right? What formula can you use to calculate the sum of an infinite geometric progression where the common ratio is less than 1? Okay, so let's take a look at it carefully. If you this is formula for calculating this particular sequence, right? Where you have n, but now we are going to replace the n with infinity, and this is 1 minus r. So if you have a number that is less than 1 and you take that number, so in this case the number is 1 over 2 and you take infinity of that number, what are you going to get? You're going to get the following. You're going to get something like this. You're going to get 1 over infinity divided by 1 raised by infinity divided by 2 raised by infinity. 1 raised by infinity is 1 because if you multiply 1 as many times as possible, you're going to get 1. But 2 raised by infinity will give you infinity because if you keep multiplying 2 by itself many times, you get a very large number. So what is 1 over infinity? 1 over infinity is 0. So what this implies is the sum to infinity for this kind of sequence is a divided by 1 minus r because this becomes 0. 1 minus 0 is 0 and eventually you have this. So this is sum to infinity. So let's summarize what we have. So Sn for a case where we have r greater than 0 is a into bracket r raised to the power of n minus 1 divided by r minus 1. So this is for r greater than 0. Mind you, r cannot be equal to 1. I'm sorry, r greater than 1. R cannot be equal to 1 because if r is equal to 1, you will get the same term because 1 times anything will give you that same thing. So it's either r is greater than 1 or is less than 1. So the next is a case where you have r to be less than 1. And then lastly, we have the infinity, the sum to infinity for this second case, which is 1 minus r. So these are the equations you should take note of. So now we've talked about all the formula you should take note of for arithmetic progression and for geometric progression. In the next video, we'll talk about examples. We'll solve some examples related to sequence and series.